Hi, welcome back to Ensign Equipment. I'm Andrew Hartline, the sales manager here, and today I've got an application spotlight to go over with you on this high capacity live bottom bin right here. We're actually building 3 of them for a customer, and this is really going to get involved with materials that are being recycled. So circular economy, reutilization of plastics, it's a big thing in the news today. We see it pretty much on a daily basis, the challenges with plastics going to landfills and the need to recycle and reuse. So we get involved a lot in plastics recycling here at Ensign Equipment. This machine here is designed specifically to handle a light filmy material or a flake material that is highly compressible. We actually have the customer's material here that we're going to be running tests on for them. So this is the ground up recycled film that they're going to be processing. It's quite compressible if I squeeze it, and what is the challenge here is in a typical hopper, material like this tends to bridge. So when it's stored with a hopper that's got 4 sides to it, all at the same angle, the pressures all come together, and then we get this bridging effect in the hopper, and it doesn't drop actually into whatever it's trying to go into. And in this instance, it's trying to drop into a vacuum conveying system. So one of the big value adds to high capacity live bottom bins, or some other manufacturers call them agitator hoppers. They go by different various names, but the advantageous part is that the sidewalls of the bin on 2 sides are very steep, 70 and 80 degrees typically for us, and then the other 2 sidewalls are completely flat. So we don't ever have any 2 sides having the same angle, which doesn't create the bridging effect. In addition to that, most oftentimes we're adding agitation to them to keep the material conditioned and fluffy and in a flowable state, and not allowing that head of pressure from the above material to cause that bridging effect. So high capacity live bottom bin, it's a storage vessel. It's got a horizontal screw conveyor that runs on the very bottom of it. Our control panel here that's mounted on the machine has variable frequency drives for both the agitator as well as the auger. So on the auger side, they're going to be able to dial in the throughput rate they need when they call for material. We also have reversing controls here, which we'll highlight later on, the door for that. But here's a spring-loaded switch that they're able to hold to help evacuate any residual material in the hopper when they're doing product changeover. We've got an access door also for the same reasons. It gives visibility for the operator to see inside, make sure the hopper's clean, or get an air wand in here. What's upstream from us that's going to be mounted on top of this is a blender. So they're going to be repurposing the regrind film flake, and then they're also going to be blending it with virgin pellets, and both materials will be dropping into our bin. So the blender has an existing high level switch, so we've created a port for that in the side of this side of the bin, and then there's a view window here so they can also visually see inside the hopper while it's in operation. If we circle around to the other side, this is the clean out door I was referencing earlier for the reversing controls. So this is a swing door with an electrical interlock that once they open it, the auger is no longer capable of running in a forward direction, and then we've got a reversing controls that has an audible alarm to help signify to any operators in the area that this auger has an open end and will be running in reverse for clean out purposes. The discharge end, we discharge into our discharge box, which is designed to adapt to our standard vacuum takeaway box. And then this one is designed for a 4-inch OD material conveying line. So our controls are also set up to tie into the existing pneumatic conveying system. We only want to be delivering material into the vacuum takeaway box when the downstream chamber is calling for material. And so we have interlocks and contacts in our control box so that when it calls for material, that's when our auger turns on and we deliver material into the VTA box. If there were to be some type of challenge with the controls, or we missed a signal and our machine started conveying, we do have safety features to ensure we don't destroy the auger, or we don't agglomerate the material under intense pressure by conveying it into a deadhead position. So we've got an overfill switch here, which is a pressure rated switch, so that if material starts to build up, it will shut the auger off in those instances. I mentioned that the material that we are going to be conveying here is compressible, it doesn't flow well, it bridges, and that we condition it with a rotary agitator. And so you're going to see as the material is entering into the bin and sitting resident, and this agitator is moving, how it keeps the material conditioned and in more of a flowable state. That's one of the best features I can say of one of our high capacity live bottoms, is the ability to always make sure that even the hardest flowing materials are able to get into pneumatic conveying systems and into the downstream equipment that's reprocessing them. So I hope this information brought you some value. If it did, please like and share with your cohorts in the industry. We'll catch you on the next one.